Hello everyone, welcome back to my YouTube channel. In our previous video, we have discussed a simple experiment to observe does the electric current have influence on the magnetic effect. So we have performed a simple experiment by considering three cases. That is, one is switching on the circuit and observe the compass needle and note down the observation. And in the second case, when we switch off the circuit, what happens to the compass needle? And in the third case, when we move the switch between on and off position, what happens to the compass needle? So from these three cases, what do we observe? What do we infer is, you may have noticed when the current flows, the compass needle gets deflected from its original position. But when you stop the flow of current or when you switch off the circuit, the needle return to its original position. That means when you switch on, it gets deflected or it moves from its original position. When there is no flow of current, it will come back to its original position. So we all have studied in our earlier classes that the compass needle itself is a tiny magnet. It acts as a tiny magnet which deflects when the magnet is brought near it. So when there is flow of current, it acts like a magnet, and this magnetic effect can act through any non-magnetic materials kept in between. So whatever the non-magnetic materials you take and keep it in between, it acts like a magnet. But why does the compass needle deflect when the current flows through the wire? So what does that deflection indicates? Why it is moving? The deflection indicates that the current carrying wire has a magnetic effect on the compass needle. Hence, it deflects from its original position. Whereas when the current stops, this magnetic effect disappears and hence it returns to its original position. And the region around a magnet or a current carrying wire where its magnetic effect can be felt, such as by the deflection of compass needle, is said to have a magnetic field. When do we say that there is a presence of magnetic field? See, when the current carrying wire or a magnet where you can see the presence of magnetic effect, that means when it attracts or when the compass needle deflects, then it is said to have a magnetic field. And next, what do we mean by this magnetic effect of electric current? When the electric current flows through a conductor, it produces a magnetic field around it, and this phenomenon we call it as magnetic effect of electric current. Hence, in our previous video we have discussed that the iron nail attracts the iron paper clips when there is flow of current, because when the current flows, it produces a magnetic field around it, and this phenomenon we call it as magnetic effect of electric current. Hence we can say that the electric current and magnetic effect are interconnected. So I hope this video is informative. If you find it useful, please share this among your family members. If you have any doubts, please drop your doubts in the comment section. I'll clear it as soon as possible. Thank you.